Welcome to this talk on microservice patterns. You may notice that I've removed the 7 in front of my title. And that's actually good news for you because I have 8 patterns, or 9 actually I'm going to show you. So we have a lot of stuff to do, and I'll show a lot of demos. So I'll try to sit down and have this mic and this napkin holder and hope you can hear me. So let's get started. Some words about me. My name is Ivar Grimstad. I work for Cybercom in Sweden. I'm a principal consultant there. I'm also a Java champion, and I'm in the Java Community Process Executive Committee, as well as also the new PMC for Eclipse Enterprise for Java, where I'm actually now the first month acting as a PMC lead of that project. I'm also a NetBeans Dream Team member, and I run the local Java user group in Malmö, Sweden. So today's talk is about microservice patterns. And there are quite a few of them. And I'll go quickly through, show a couple of slides, just mention what the pattern is about, and then I'll show some implementations of it and how you can actually see it in code. So I'll be using a lot of microprofile stuff. Some of you have got stickers for microprofile. I have more stickers there, so just approach me after the talk. I'll show a demo of everything. I'll be using microprofile, Java EE, Spring Boot, etc. to show the stuff. So that was the introduction, and let's get going with the patterns. The first one is actually the main pattern, which is called Microservice Architectures. And the problem statements for Microservice Architectures pattern is what's the application's deployment architecture. Right? It's about the deployment of the application. And if you look at the monolithic approach to applications, you have everything as one big unit. So you deploy it as one unit. And that's the important aspect about it, is that they're treated as one unit. You often have a common data source or common dependencies to it, and it's treated as one unit. So if you do a change somewhere in your application, you're going to redeploy the entire thing. That's the characteristic of monolithic architectures. And that's the problem that microservice patterns or microservice architecture pattern is trying to solve. So even though you have a monolithic architecture, it can be divided into smaller components. It can be really well structured. It may serve your purpose well, so it's not necessarily that everybody has to go towards microservices. A monolithic application can be very good in most cases. But as I said, the important characteristics about the monolithic architecture is that it's treated as one unit. So if you make a change to, for example, the database schema, the entire application has to be redeployed, potentially. So the opposite, or the counter to monolithic architectures, is microservice architectures. And that is where you split your application into smaller services. And these services do one thing, and they do it extremely well. And they typically serve one business domain. And in this picture, I've written that you have the application that is calling services A, B, and C. But the application may also very well be a microservice. So you can have services calling each other, but the important thing is they are treated as one unit, each of them. So each microservice may also be a complicated and well-structured and have lots of components and the usual design patterns you use to build your application within each unit, but you deploy them individually. So if you make a change to one of the services here, this is the service that you redeploy, and these are potentially not affected at all. And typically, you would have one data source per microservice. And this gives you the flexibility to actually have different data sources. So you can use a NoSQL approach where that's appropriate, or an old-fashioned relational database where that is appropriate. So this is the overview of the microservice architecture, and you see the main patterns which we're talking about now is the microservice architecture patterns. And you have lots of patterns that are connected to this. For example, this database per service. You use one database per service, you don't share the data source. And I'll go through a couple of these today, among them API gateway, externalized configuration. I'll go through health check APIs, and yeah, some more. I can find them. Yes, the circuit breaker and the discovery mechanism. So we'll look at these, and they're all connected to this main pattern, microservice architectures. So that concludes pattern number 1. I don't have demo for pattern number 1. Demos come later. I don't have a demo for pattern number 2 either, because it's very simple. So the API gateway is how do the clients of a microservice-based application access the individual services. And as you remember from my first slide here, this is typically how you have the application call or the different services called service A, B, and C. But kind of to abstract the way that they are calling service A, B, and C, because you're not necessarily interested in knowing that you're calling service A, B, and C, you can introduce a API gateway on top of that. And the API gateway can take care of things like security, access control, etc., etc. And related to API gateway, you have backend for frontend. So that's a variant of the API gateway pattern. And it solves the same problem. It's how do clients of a microservice-based application access the individual services. And so you have the API gateway like this, and you have the application, but the picture isn't usually as simple as this. You typically have different kinds of clients. Like, for example, you have a web application and you have a mobile application. And these applications aren't necessarily interested in the exact same API. So rather than exposing all the API through the API gateway to both clients like this, you can split the API gateway and have a specialized API for your web application and a specialized API for your mobile application. So we have a mobile API gateway and a web API gateway. And this is what we call the backend for frontend pattern. And there are several services out there if you're in the cloud. I've listed a couple of them here, Amazon, Microsoft, and Google, where you can configure the API gateways in your cloud environment. So now that was the simple patterns. So now we go into the patterns where we are going to show some demos. So pattern number 4 is service per container. And the problem statement of this pattern is how are services packaged and deployed. That's what this is all about. And look at this picture. If you have the Uber jar approach, which is very popular in the microservice world, is that you typically, since we're talking Java here and all these Java-based microservices, you typically have some kind of hardware or virtualization layer. You need to have some operating system to run on, and you need the JVM. After all, we're talking Java here. So, and the application contains everything else. And the package inside your Uber jar or fat jar or whatever you want to call it is completely self-contained. It contains everything you need to run. So you can typically run it from your command line with java-jar and your jar file. The other more application server-oriented approach is to have a thin WAR. So this is the thin WAR approach as opposed to the thick or fat jar or Uber jar approach. And this is where you still have the same hardware layer, operating system, and the JVM. Since we're Java, that's the minimum of what we need to be able to run our services. But in this case, we also add another layer typically called the application server or the Java EE container. And the container contains capabilities and stuff that you would need to run your application So you don't need to repeat yourself and write it for every service. And you don't need to bundle it into your application because it can just use the services of the underlying mechanism. And the way you would deploy this one is to have some kind of deployment script that is typically special for your particular choice of a container. So if you're running on WebSphere, for example, you have one deployment script, or if you're running on Wildfly, you have another deployment script. So the deploy Dukes script. Then we introduced the microprofile way of doing it. Is that we still have rather than the Java EE container, we replace it with a microprofile container. So it's a thinner, more streamlined container. And this one can be packaged as a UberJar, or it can be packaged into a application server the same way you would do with the Java EE. But the deployment mechanism is in this case also specialized towards which vendor you're chosen to run on. So it will differ if you run on Wildfly, Liberty, or Tommy, or Priara, for example. But the mechanism is the same. You have some underlying services that you rely on to be able to run your application, and your application is a thin war as opposed to a thick jar. And then you add Docker to the equation. And Docker is another container. It's a container on top of the different container mechanism than we talk of when we talk about the Java EE containers. So Docker is a containerization mechanism. So we package our applications into a Docker image and run it as a Docker container. And from the outside world, all of these are similar. All of them are run with Docker run or using whatever orchestration framework you're using to run it. So here it doesn't matter how you package your services internally. And Docker only relies on still some hardware or virtual machine underneath, and some parts of the operating system that is required to run this particular container. But from the outside world, it's exactly the same. Whether you're using a thick war, a thin microprofile war, a thick jar, a thin microprofile war, or a thin Java EE war. From Docker, it's the same. And one thing that is important to notice about Docker is that it's layered. So whatever you put in here, the top layer would be your application. So if you think of the bottom layer here of being the parts of the operating system that you need to be able to run, and the JVM, and you have one layer which is the application server, and your top layer is the thin war, either Java EE or microprofile. This is a layer that you're actually swapping out when you update your application. So if you do a change in your application, it's the application layer you swap out, and in the thin war approach, this layer would be thin. You're talking kilobytes over the net rather than megabytes. If in the UberJar approach, the top layer would also be bundling together all the services that your application requires to run, so it will be more a thicker layer to swap. So it's more expensive to update your application. So here is the picture. And the UberJar approach, the application that you're actually building, when you do a change, you update a small line of code in your application, you rebuild the entire stuff and package it as a jar file, and this is a layer that is uploaded to your target environment. In the thin war approach, it's kilobytes. Here you talk megabytes. And from the outside world, it's Docker run. So let's look at some ways of doing this. I'll put the mic here. So, okay, still hear me? Good. So, I'll show you a couple of ways to get started with microprofile first. And in this case, it's the Wildfly Swarm. Anybody using Spring here? So, yeah, so you know the Spring.io site where you can sort of generate a project and get up and running pretty quickly. Well, this is similar stuff. So here I just say that I want to call my application something. I go here and say I want to have a microprofile, and it's generate the project. And I get a zip file. It's unzip, maven install, and run. So it's just as easy to get started with this as it is with Spring. And this is how Red Hat has done it for Wildfly. IBM has done a similar thing for Liberty. So here you can go in, just choose the microprofile, call it whatever you say. I want beta version, generate the project, and run maven install, and you have WebSphere up and running. So it's one click, unzip, run. So it's pretty fast to get started with. The other implementation of microprofile don't have the similar generators, but they have similar ways of getting started easy. So I'll show one microservice microprofile implementation here called Cumulus, and this one is kind of interesting because it doesn't come from the old Java EE world. This is based on Jetty, so it's kind of a new player on the field. And the way you're using the Cumulus, this one is for microprofile 1.0. Microprofile 1.2 is out now. I'll demo something of that later. But the way you use this is that you add the things from Cumulus that you need in this project, and here I'm just using the basic microprofile. And then I can use the Cumulus Maven plugin to just package my application. And this one will create an Uber jar for me. So what I also can do here is to use the Fabricate Maven plugin to generate my Docker image. So based on my jar file, I just say here that I'll generate an image. I'll run on Oracle Server JRA. You can choose whatever Java VM you want to use. And I just copy the jar file into the Docker container, and I say that it's going to run by just running java-jar and this file. So it's pretty easy to set up with a couple of main plugins, and I'll show you how it runs here. So I build it with Maven package. Here I'm not using the Docker image for it. This one will build, and then I can run it from a command line with java-jar target Cumulus jar. So this one will fire up my application, and it's a really simple application. It just saying hello. So it has a hello resource saying hello from Cumulus. So this is Java EE, but on microprofile. So then I can look at it and say hello. There we go, and it says hello from Cumulus. So it's very fast to get up and running. Cumulus also have a generator, but I noticed this morning that it's actually not working anymore for some reason. That they've moved it from the page, but you can go in here and click the generator, but for some reason it worked this morning, but not anymore. But you can find enough information here to get up and running with it. It's pretty cool. Okay, so I'll also show you how you can build a Java EE service with using Docker. So here it's the same service. It just says hello. This is actually using some configuration stuff. I'll show that later. But it says hello world from Java EE. And the same way here, if I want to run this in a Java EE container. Here I'm using the Java EE web API, not the microprofile or anything else. I've added some configuration here to be able to use that, but it's not really needed. And then I can have set up my Docker plugins, whether I want to run it in Liberty, in Payara, in Wildfly, or in Tommy, or whatever application server I have chosen for this particular service. And the way I build this one is exactly the same. Let's see, there. Maven package, Docker build, and I just choose the profile, for example, Tommy. Maybe spell it right. There you go. So this one will build first a thin war, and then it will generate a Docker image for me that contains my Tommy application server with my war file in it. So if I look at what's generated for me, I'll move it up. So you can see I have the war file generated for me. And it will also generate a Docker image for me, so I can just run it with Docker run 8084, for example, 8080. So this one will start up Docker with Tommy inside of it, and my application will be deployed in Tommy inside my Docker container. I think it's thank you. There you go. So this one says hello from Tommy then. We're doing on time. So in this demo here, I showed you how to set up the different, how to use Maven to build your Docker images. Because you don't particularly want to have to be able to or you don't want to have to write your Docker file manually. You want it to be generated by a build server. You want it to be done in your build process, so you can run it on your developer machine or whatever. The different images you can choose from it. You can find them on Docker. Here, an example from Webs for Liberty. They provide images from microprofile if you're only relying on the APIs that microprofile is providing for you, or you can use the full Java web profile, and your service will be this small application on top of this. And the important thing here, this is a thin war, so no matter if your total Docker image can be kind of big because of the application server in between. Your application that you're swapping when you do changes, because that's where you do changes, is the top layer, and that's the only thing you have to send over the net. And if you look at the differences in size here, they have slimmed it down now. The new Open Liberty is like, I think it's 79 megabytes or something. So this is the microprofile Webs for Liberty, the old image. That was around 200 megabytes. And the full web profile was 230 megabytes. So it's not that big a difference whether you choose to go for microprofile or web profile. There are other advantages to go into microprofile, and I'll show them in a little bit later in this talk. They have added some stuff that is pretty good for you when creating microservices. If you look at Payara, for example, they also have different images, and for microprofile 1.0 is only 80 megabytes. For the microprofile 101 support is, they just released the 174 version yesterday, I think. But here's the 173 is like 130 megabytes, and the bigger is bigger. For Wi-Fi, Swarm generates a jar for you, so you're running on the JRA. This is the OpenJDK Slim version. So this is similar to what you would do with Cumulus, for example. And Wildfly is like the size of Liberty. Tommy also is about 200. It's about the same size as all of them. But don't want to run your containers like I do here with Docker run. You want to do some use some container orchestration mechanism. And out there, the big players today is Apache Mesos, Kubernetes, and Docker Swarm. And Kubernetes is probably the most widely used one. But no matter what cloud provider you're using, they probably support at least 2 of these, or maybe all 3 of them. So you can choose whatever fits your purpose. So let's talk about configuration, because configuring your microservices is also important. So we looked at how we can package them, and we're running them, for example, as Docker containers. And we also want to configure them. And the problem statement for externalized configuration is how to enable a service to run in multiple environments without modifications. Right? You want to build your deployable, whether it's a jar, a war, or a Docker image, you want to build it once on your build server. And then you want to run it in different environments. You don't want to have to recompile your code because you change some IP addresses or some environment properties for another environment, because then you're not running the actual deployable that you tested. So you want to run your same deployable in all environments, but you want to configure it differently. So one implementation of this pattern is the configuration APIs for microprofile. And this is now a version 1.1, I think, and I'll demo it in a minute. The way it works for microprofile or this is that the higher order of properties you set, they will override the lower one. So if you have a system property set in your environment wherever you run your application, this is override any environment variables that you've potentially set there. For example, if you set environment variables when you build your Docker image, but you want to run this container, this image in another environment, then you can set system properties outside of it and override the environment variables, if that's what you want to do. Or you can set environments variable and override the internal environments variables. And when you run the application on your laptop or your developer station, you want to run it maybe from your IDE, and then it makes sense to have some configuration inside the application. So you can have a configuration file inside your application that you run on your local machine, and when you deploy it to your test environment, you set some environment variables there, and it behaves a little bit differently. And then you deploy it to your production environment, and there's another set of environment variables there. So it's the same deployable, you don't redeploy it, but you can use different ways of configuring it. And these are the stuff that comes as default. There are also ways of creating your own configuration sources, so you can pull it from a database or GitHub or whatever you want to configure a system from. The configuration API is also filed as a JSR. It's JSR 382 through the JCP process. What actually will happen to this JSR is a little unknown now that Java E is moving to EU4J and Eclipse Foundation. But if it continues, that's the JSR that we specify the configuration for Java E based on the microprofile, and it's run by Eclipse Foundation. I also did a small open source project called Snoopy. It also has some simple service configuration in there. So if you want to play around with some simple Java E code that is on GitHub open source, you can just download it and try it and play around with it. The way Snoopy works is about the same way as the microprofile config, only I've introduced a configuration service. So I have a discovery service. I'll talk about discovery mechanisms later, but I have a discovery mechanism that this Snoopy configuration service registers itself with. Then the application, the different service here, service A, also registers it with discovery service. Then it asks the discovery service, hey, give me the config. And then it gets a reference to config service, and then it says, hey, give me my configurations. And it gets its configurations And then the application can also look up config and get the configurations it needs to be able to run, and then they can run. So let's look at some code here. Let's stop this one. There we go. So in this demo, I'll be using Wildfire Swarm, and Wildfire Swarm is the microprofile implementation of Wildfly from Red Hat, and it has a very modular approach. It's kind of similar to how you would set up Spring Boot, that you add the fractions or the components that you need to be able to run it. So in this case, I say that, hey, give me a microprofile 1 of 1. And from that one, I want microprofile, and I want the microprofile config. And then I have the Wildfire Swarm plugin that packages the stuff for me. I also created a profile to run it in Docker, but yeah, we can do that as well. The actual source here is, look here, is that in my hello resource, I'm injecting a config property, and my config property here is looking for a configuration called place, and if it can't find it, it will use a default value called world. Right? So it will say hello world if it can't find any property for place, and as you see, the config property is a microprofile annotation. So this is all I actually need to do in my application in order to be able to use a configured place in my hello message. And if I don't give it a default value, then this property will be a required property. So if I happen to run this application without a default value in an environment that doesn't specify this property for me, I will get a runtime, a startup error at runtime, so I will know that, hey, this is a required property, you have to have it to be able to run. And in some cases that is good. In other cases, you can supply some default values for it. So if I build this one, go there. Configured. Package. So this one builds a WAR file for me and a jar file, since it's using the Wildfire Swarm plugin. So I can run it from command line, configure to swarm jar. So this one will start up, and it will list whatever fractions I've enabled for this particular service, and it's up and running. So it's pretty fast to start as well. And it's configured duck, and it says hello world from Wildfire Swarm, and that's because I've configured it to be with the default value, right? So what if I want to configure this a little bit in my developer environment? Then I can go in here and open the microprofile config properties file and say that, hey, I want place to be a Devox MA in my on my computer. And in this case, I'm actually doing a change in the code, so I have to rebuild the application. So now it won't use the default value, it will use the configuration property I've set in the configuration file. And if I run it the same way as I did, it should now say hello from Devox MA. And it does. So this is how I can configure it. But what if I know I'm happy with this, this is how I want to have it configured, but I want to move it to another environment. Let's say I go to another conference and I want to present there, or I want to have another location. Then I can give this some input arguments here. So I can say I can give it system properties by -d. I'll just dash place is Casablanca. So now I give it a system property value of Casablanca or Casa. And if I run it now, it should say hello Casa. So now I can move it over to another environment and give it another property without rebuilding my jar file. So that's pretty awesome. And also, this one will also play directly into if you're running in Kubernetes, for example, and set environment properties there, it will pick them up like this. So it's very convenient there. And I can also set environment variables. I'll do that in the Docker. Let's see. I haven't done that. Yeah, but you get the point. You can also set the environment variables and run it. Yeah, I can run it. Let me build it in Docker and show you that. If I say Maven Docker build swarm, I'll run it with the same. So it creates the Docker image for me, and I can run it with Docker run. I can run it on. Sorry. Yeah, I'll put it in. 8080, and then I can give it a environment variable. Say place is Morocco. Like this. So now I set an environment variable in my container when I start it. I can also do it when I build the image. This makes more sense. So when it started, it will say hello Morocco. So the configuration API is super easy to use, and you can also use it with Java EE, as I showed you here. This is the Java EE project I was running in Tommy. Actually supported. You just need to add an implementation of the configuration API. And in this case, it's the reference implementation called from Geronimo. So I can also configure my Java EE application using this. You just need to add both the API and the configuration and the implementation. So if you're already in EE environment, this is how you get up and running with the configuration there. So that was configuration. Let's move on to service registry, and we have to speed up a little. I see we have a shorter time here. So service registry is how do clients of a service know about the available instances of a service? And typically you don't want your services to be tied together as this. Oh, sorry. There we go. So you wanted to do a lookup to a discovery service after the services register themselves as startup. You want the application to look up the service before it calls it. In case service it's looking for is down, then you want it to be able to handle that. So if service B goes down and the application asks for service B, it should get something else. Implementations of this is Eureka. You've probably seen demos of Eureka before, so I'll skip that since we're short on time. Snoopy is another example of this. I'll give you links to it so you can try it out yourself, but I think we'll skip this demo since these discovery mechanisms are also available in the orchestration framework you're using. If you're using Kubernetes, for example, you have a discovery mechanism there, so you don't really need these. These are only needed if you kind of do it manually yourself. But feel free to look at the links and try them out. They're well documented and pretty easy to get started with. The circuit breaker is a little bit more interesting. So how to prevent the network or a service failure from cascading to other services. So if one service is down, you don't want everything to be down. And the circuit breaker's name is like the fuses in your house, right? If something goes wrong in one of the rooms, a circuit breaks, so that the other appliance in your house will still work, but this particular circuit is open, so you don't burn down your house or anything by using it. Examples of circuit breakers are Hystrix from Spring Boot or Netflix, and also MicroProfile. And I'll demo the MicroProfile circuit breaker very quickly. So the circuit breaker I'll be showing here is running on WebSphere Liberty. It runs on the MicroProfile 1.2. And the way it works is I can configure my application saying that this particular service has a timeout of 3 seconds. So if it's more than 3 seconds, it's going to time out. And then I can add a circuit breaker to it that will wait 1 second, and after 3 failed attempts, it will not call this, it will break this circuit, so you won't be able to call this service anymore. The way I'm provoking this to happen is that I'm saying that the first 3 attempts to call this service, I'll just have thread sleep for 10 seconds. So I'm pretty sure this will be more than 3 seconds, so the circuit breaker will shut it down. So let's see how that works in the client. Let's just run it. Package. So to make sure I have the latest code. So this one is using WebSphere Liberty, or the MicroProfile version of Liberty. So I'm just I can run it from command line, tolerant Duke, jar. Oh, it has another name. It's tolerant Duke jar. So this one will start up WebSphere Liberty. And if you're working with Liberty, you know this is traditionally a very slow thing, but in MicroProfile, it's already up and running, and you can use it. So it's really super fast. And let's try to simulate this circuit breaker thing. I need 4 browser windows. Localhost 9080. 80. Healthy Duke API. Hello. So this is the stuff I'm going to call, and I'm going to do it 4 times very quickly. So I start here. 1. Okay, didn't find it. Sorry about that. What did you say? Consider root not found. Okay, it's because it's not healthy Duke, it's tolerant Duke. Sorry about that. Okay. So there you go. There. So what, if I invoke this one now quickly in all of them, it will. No, it shouldn't do this. I haven't built it correctly, I think. It shouldn't do this. Sorry. A demo isn't a good demo unless it fails, right? Let me see what I've done here. I've taken away the fallback handler. I should bin package runnable. So let's try again. 1, 2, 3, and 4. So it should take 3 seconds, but it doesn't work. So okay, let's skip this demo. I'll record a video or something, and I'll show you later. What I will show you is the health check API, and together with this, I'll also demo the ninth pattern. And the health check is how to detect that the running service is unable to handle requests. So if you have some kind of orchestration framework around, for example, Kubernetes, or you're using Snoopy or Eureka, you want to have a health endpoint, so the discovery mechanism or the registries can know that this service is up and running and able to handle requests. And you don't want to code this for every single service you do. You want to have some easy way of configuring it. And Microprofile Health provides this for you. And I'll show you a demo. I'll just go through the next pattern and do that demo at the same time. And that is application metrics. You also want to know how your application behaves. So this pattern addresses the problem of how to understand the behavior of an application and troubleshoot problems. So in this case, you want to have metrics for your application, and you want to have simple. You don't want to have your application code actually doing the metrics for you. And Microprofile Metrics project provides this for us. So let's show these two in a demo. And I have here the Healthy Duke, which implements this stuff. And in this example, I have a simple Java class, which is annotated with the @health annotation from the Microprofile Health, and implements the health check interface. And what I do here is just to override a simple method that I can do some coding. I can say that it's up or it's down, and I can give it some more data, whatever I want to do. So here I just say Duke rocks, and returns this as a successful check. So I don't provide it any endpoints or anything. I just say, hey, have this stuff in the code. So what I also can do here is in my hello resource, I can say that this hello method here is going to be measured and be able to get some metrics out of it. So I'll add the timed annotation here, which is from the Microprofile metrics. So this one will give me metrics about this hello method. So every time this greet method is called, I'll get some stuff out of it. I can also give it some attributes here, but I won't go into details. So if I take this one, stop it, Healthy Duke, and clean package, oh. This one is also running in Web3 Liberty. Target Healthy Duke. So we're up and running here, and here you can see it writes here in log the endpoints where you can access this these services. So I can go in here and say on localhost go to health, and then I get the stuff, and here you can see the message I added by myself. So you can configure this as you would want yourself. I just added this class somewhere in my application with the correct annotations, and I get a health which says it's up here. And this one can check for some database connections or whatever you require for it to say that it's up, and then say it's down. And the other services will be able to use this. The other thing is the metrics, and this one runs on HTTPS, so I just have to go there, log in. So here I get a lot of metrics about my application, but all of these have the type base. So if I want to go in here and go into my Hello API and said, this one says hello, and I invoke it a couple of times. I refresh this page. You see that I also now have the application metrics here. And I can go in and filter these out and only see my application metrics. And here I can see, here I can see that I can see how long it's running. I can see how many greets per second has been. And since I'm not using it now, you'll see this will be smaller. I have greeted 6 times. So if I go in here and press a couple of times more, it will say, hey, I've greeted 11. So I can have the count of invocations on this endpoint, and I also have the metrics around it, how much CPU it uses, etc., and rates per second I am able to serve. So this is pretty good stuff for operations personnel. So let's sum up quickly. We've gone through a couple of these microservice patterns. I'll show you a link where you can find more of them, and also the figure. These are the patterns we've gone through. The overall patterns, the API patterns, the service per container, externalized configuration, the registry, circuit breaker, health check, and application metrics. The webpage called microservices.io is a webpage where you can find description of all these patterns. So this is the way to go to read about the patterns. For the samples of this application, you can go to my GitHub, the microservice patterns, or the Duke microservices project. For Java EE is on GitHub. You can find all the APIs there. For microprofile, go to microprofile.io and find a documentation about all the different APIs, and you'll find demos and samples and everything out of that. I'll also publish these slides after this talk. So that's what I had. We've got 2 minutes over, but it's still 8 minutes to lunch, so you won't miss that. It's been cool. I'm sorry about the demos that it didn't work, but if you see me around, just approach me and I'll run it for you outside here afterwards. So please feel free to approach me. So thank you very much for listening, and thank you for having me here.